All right, dividing powers of 10. You might even be able to predict what this will look like. When we multiplied powers of 10, just a reminder, 10 to the third times 10 to the fifth, we said it was 10 to the eighth. Not to be confused with 10 to the third 5 times, which is 10 to the 15th. That's what we covered so far, right? Those are different, but those are the rules we've talked about. Now today, let's just see if you can guess. What do you think that will be without any knowledge of the situation? Now think about it. What did we do to the exponents when we multiplied? You added them. So what do you think you're going to do when you divide? Yeah, that's the whole lesson right there, in a nutshell. Okay. Looking at the first question, what is the value of the following expression? Okay, so I have 5 2's on top. If I just write this out, I have 4 3's, and I have 2 3's, and I have a 2, I got 3 6's, and I got 2 more 4's, or 4 more 2's. Seems like a lot, right? I just wrote them out. This is why we use exponents. So if you were to just start canceling things, you will notice your answer to that whole thing is
0.
1. Same thing on top and bottom is 1, right? If you have a fraction, the same thing top and bottom, you don't say that's 0.
Can there be an exponent?
Your answer is 1. The exponent would be 0. Anything to 0 power is 1. Yes. Yeah, your value is 1, and that's what we're going to be looking at today. And again, we're going to have both of those things we talked about, dividing and 0 exponent, are both going to be mentioned today, and you're going to see a lot of them going forward. So if I take 4 10's and I divide it by 2 10's, and they show it here, I think they get a little crazy with how they expand it, but I got 2 left, right? So if I look on the next one, I have 5 10's on the top, so I'm taking 5 10's divided by 2 10's on the bottom. I think they get a little crazy again in their expanded form. I would be happy just showing what can cross out. And you're left with 3 10's. So I would like you to show this part and the single power. Again, I'd read directions. Maybe you can get out of them. See if you can finish that. Spend enough time, only a couple things to complete there. Again, you don't have to show the whole expanded thing, just that little fraction is just fine with me. I got 6 tens, show that. I got 3 tens, cross out what they have in common, and I got 3 left. Next one, hopefully you said skip by that, or you wrote out 10 60 times. What would my answer be? 10 to the power of what? 26. 43 minus 17. Which one did we skip? Well, the one where we had to write 60 tens. That's why it got skipped. Maybe you wrote it out. So if I have 10 to the n and 10 to the m, you take the top one minus the bottom one, which is what we said at the beginning. Top one minus the bottom one. Complete opposite when we added and multiplied. Question 3. Lucas, would you read that one for me, please?
It is predicted that by 2050 there will be 10 to the power of 10 people living on Earth. At that time, it is predicted there will be approximately 10 to the power of 12 trees. How many trees will there be for each person?
All right, so it's trees divided by the people. And again, that would be a big number to write out, big number to type in, but with exponents and scientific notation, it makes it easier for us. Okay, exponents here. So I can take 12 minus 10. It'll be 10 to the second, or 100 trees for every person predicted by 2050. Top of the next page, we have not talked about what happens if the bottom is bigger. Okay, well, if I have 4 tens and I divide it by 6 tens, you will notice that we no longer have extra on the top. Now we got extra on the bottom. How many tens extra, Ian, do I have on the bottom? No. Taylor? 2. So the top is completely canceled out. I got 2 extra tens on the bottom, so it's 1 over 10 squared. And now we haven't talked about this, but that actually can be written as a negative exponent as well. Negative exponent doesn't mean your answer is negative, it just means it's in the denominator. We're getting to that here in the future. It's just kind of a teaser, if you will. All right, so far, all of our exponents have been a single exponent with a power of 10. What happens if I have a 0 exponent? What happens if we include that? So it says 10 to the second times 10 to the 0 with a power of 10 single exponent using the appropriate rules. So I think it was less than 2 when I multiplied. What do I do to the exponents again? I add. So I get 10 to the 12th. Now the only way to get 10 to the 12th, what number could you multiply times 10 to the 12th to get the same answer? Well, what number can you multiply anything by to get the same answer? 1. Okay, let's look at the next one, dividing. 10 to the 8th divided by 10 to the 0. We just talked about this today. When I am dividing, what do I do to the exponents? So 8 minus 0, 8. So what other number could I divide 8 to the 10th by to give me the same number? 1. So the whole point of that is if we want the exponent rules to work even when the exponent is 0, then what does 10 to the 0 have to be? 1. Okay, anything with a 0 exponent, guys, it is very important to note that it is always 1. 100% of the time. You could have 10,000 to the 0 power if your answer is 1. Question number 4. If we try to write 10 to the 0 expanded, it should have 0 factors that are 10, so it must be equal to 0. Do you agree with that? Do you agree with 10 to the 0 being 0?
No.
No, why? Because I just told you anything to the 0 power is always 1. We just proved that up above when we looked at the multiplying and dividing rules that we have already talked about. Anything to the 0 power is 1. You had one similar to this on your homework today. Write as many expressions as you can that have the same value as 10 to the 6th. Okay, I'll give you a couple. 10 to the 5th times 10 to the 1st. That would give me 10 to the 6th. I could do 10 to the 6th divided by 10 to the 0. That would give me 10 to the 6th. Why don't you see how many you can write here in a couple minutes, where your answer will be 10 to the 6th. Use the rule of multiplying. You can use the parenthesis rule that we just did yesterday. Multiplying, dividing, you can use them all. How many did you get? So a total of 4. And who got more than 4? How many you got? 11.
6, not counting them. I have
So 8.
11.
11 counting. 12. How many?
Oh, we got like one more.
One more. Nice. Nice. Good effort. Parker?
Same as Adam.
Same as Adam. You did write one, huh?
Wow.
Ian, how many you got? You got 11? 7 of them. You got 12?
Yeah.
I see. I don't know how many there are.
There's really just a lot.
Yeah, it uses as many as.
That's a lot of chicken scratch on this one.
Yep. Chicken. Chicken.
Yeah, you can do as many as you want. Guess your numbers would just get bigger.
It says money. Because it said making.
6 divided by 0, 9 divided by 3, 4 times 2, 4.5 and 1.5, even going with some decimals there. 10 and 4, dividing 12 and 6, 13, yeah, you can go on forever. No parentheses even with that one. But I can see how some of you would only get one there in those couple minutes. That was pretty intense. All right, your assignment then, 1 through 5. From lesson 4, 1 through 5. And tomorrow we're going to continue with exponents. Going to get more into negative right off the bat tomorrow. So 1 through 5 for tomorrow, please.